So let's see some principal component analysis with just the first principal component. Okay, so to reiterate what we're doing, we're going to be looking at some document vectors. I've been saying 15,000 dimensional. Now that I've double checked, these are about 10,000 dimensional. And we're going to do PCA. So we're going to take this 10,000 dimensional space and we're going to summarize it in one dimensional space, which, speaking geometrically, we're going to project it onto a line. And we ask the question, can we possibly get anything useful from this? I mean, it feels like we must be losing so much information to go from 10,000 dimensional space to one dimensional space. Surely we're not going to be able to glean anything. Okay, so here's some code. And I don't want to obsess about the details because you would not be able to reproduce this anyway, because I'm going to run this code on a bunch of EPUB files, so ebook files, and I can't share them because they're under copyright. But what this code is doing is it's going to look in a books folder and it's going to extract all the EPUBs that are sitting in the books folder. It's going to create document vectors for them, and then it's going to do PCA. It's going to find the first principal axis and it's going to show the books as points on a number line. The books I've chosen are mystery novels by Agatha Christie and romance novels by Amanda Quick. And you see, I've tagged novels as either AQ or AC, so we'll be able to see at a glance which novel is which, who wrote what. And now I am going to go to Spider. And again, the details don't matter. For example, we get rid of the first 1,000 words of each EPUB document to make sure that the author's name isn't just sitting there and giving the game away. And I run this code. And I don't know how easy this is to see. Let me zoom in. But now we have these books projected onto an axis. And we see that all of Amanda Quick's novels are over here on the right. And all of Agatha Christie's novels are over here on the left. So even though we've gone from 10-dimensional space to one-dimensional space, we can instantly see this clustering effect. All these romance novels by Agatha, all these mystery novels by Agatha Christie are clustered together on the left. All these romance novels by Amanda Quick are clustered together on the right. So PCA is based on maximizing variance. That's how the projection works. We find the line that maximizes the variance. So no one single factor is causing this clustering. Or at least it's probably not one single factor because there's a lot of variance between Agatha Christie and Amanda Quick. We've already seen one source of variance. Different genres have different words and vocabularies associated with them. So here is a source of variance between Agatha Christie and Amanda Quick, but it's not the only source of variance. One of these authors is English, one of them is American. So we can maybe detect differences in vocabulary, quirch versus flashlight, that kind of thing. Agatha Christie had an incredibly long career. But even so, we can roughly say that Agatha Christie we can say absolutely that Agatha Christie novels are older than Amanda Quick novels. So there are going to be differences caused by this, variants caused by this. Old-fashioned vocabulary versus contemporary vocabulary. And this isn't causing it, but, potentially words like Poirot could be showing up a lot in Christie and not at all in Quick. That's not happening because I'm using non-series novels. I'm not using Perot novels. But we have this recurring character with recurring side characters, and that would be a source of variance. That the character Poirot shows up in a lot, could show up in a lot of Agatha Christie documents, but not any Amanda Quick document. So, so this axis doesn't represent any single thing. That's maybe the thing that's most unintuitive, but the thing we have to grapple with. This axis is looking for variance. So this axis is finding all this variance, but this is not a mystery versus romance axis. This is not an old-fashioned versus contemporary axis. This axis is finding variance, whatever is causing that variance. Now let's add some more data. Rex Stout is another mystery author. He is let's see, he's an American mystery author, less contemporary than Amanda Quick, but more contemporary than Agatha Christie. His last novel must have been around the time of the Watergate scandal. So PCA depends on the data. So now that we have a different data set, we're going to create a different principal axis, and we're going to project everything onto it. And this. And let's again zoom in. So on the left, we have now Agatha Christie and Rex maxed out. And on the right, we have Amanda Quick. Let's add some more data. Edward Hotch, a contemporary mystery writer. So another mystery writer into the mix. Go back to Spider and see what happens. Tum tum ta tum. There we go. So it really does seem like there's something about mystery novels that is just, in terms of the vocabulary they use, that is just fundamentally different from these Amanda Quick romance novels, because we're constantly seeing these clusters, the mysteries all on the left, and then the Amanda Quick novels on the right. Let's throw in John Dixon Carr, another mystery novelist, writing at the same time that Agatha Christie did. Dara Joy, a contemporary romance novelist, as you could perhaps tell from the pseudonym. And now we go back to Spider and let's run it again. Did I perhaps not press run? Or it's just taking a while? So now we see, well, you probably can't see, you probably think this is an impenetrable cloud of text. But all of the mystery novels, I should say, are together down here. The Dara Joy stuff is mostly here. The Bride of Newgate by John Dixon Carr is far from the rest of his novels. The Bride of Newgate is also a different genre. It's a historical adventure novel. And then Amanda Quick is over here. So there really does seem to be something fundamental about the vocabulary of mystery novels, that when we do these projections, we can very clearly see them group together. Now, we've gone from about 16,000 dimensions now to one dimension. And inevitably, there are going to be important things that are not captured in one dimension. Like, this is looking really nice so far, isn't it? You know, the mysteries have all clumped together. Amanda Quick has sort of clumped together, although they're a bit spread out. Same with Dara Joy, sort of clumped together, but kind of spread out. Let me add, finally, Faust, part one and two. The German plays. I can never pronounce the author. It's spelled something like ghost. Let me throw these in, and something weird is going to happen this time. Um, Whenever this finishes compiling, something weird is going to happen. And that is that these novels, written by the same author, the same genre, the same style, you'd think the same everything, but they're really spread out. So the moral of this is that, you know, there are limits to looking at one dimension. We're taking these huge data sets, now about 18,000 dimensional, and we're projecting them onto one dimension. And we've seen a lot. We've seen a lot of great stuff. We've seen the mystery novels cluster together, but there are limits to what you can get with one dimension. So fortunately, principal component analysis generalizes, and we can look at more than one dimension, and that will be our next video.